Hi, welcome to PiSquare Academy, which is India's first and only smart gate coaching institute. In this video, I'm going to give you an interesting analysis for the situation of 5th April light-off call, which is called by Prime Minister Modi towards COVID-19. I mean, how this situation can affect the stability of the grid, which most of the electrical engineers are thinking about. And what are the electrical engineer role, how electrical engineer should be ready to face this situation. What are the measures should be taken care by load dispatch centers and generating stations also? And what is your role at your home towards protection of the grid from instability? I will give you complete analysis by considering the real-time data. You are definitely gonna get some good insights and analysis, so watch the video till the end and share this video with your friends. All the information which I'll be using throughout the video is a real-time data from POSOCO website. So complete information is 100% genuine. You can also see the data from the website. Links will be given in the description. You can go through the links. Let's get to the analysis. Yes, look at this. This is all over India demand graph in megawatts. Careful, the unit is in megawatt. You might be thinking there are a lot of changes over here. There is a huge change, but see, from this is 100 gigawatt to 150 gigawatt. Okay. So, or maybe if you add these three digits also, you will get megawatts. Anyways, point is, this is the data from the last year, okay, and these three are the last weeks, okay, the present week 29 to 4 and previous week and previous to that week. So, weekly data as well as previous year data also has been given here. I'm not concerned about all these things because present situation is completely different. So, I want to rely for my analysis, I want to rely on this week analysis, means last 7 days analysis. So for the sake of simplicity, I'm just clearing all these things. I'm putting only this line, okay? I'm just keeping 29th to 4th, okay? So I'm just keeping that data, okay? Today is 5th. So what will be next, okay? What will be today? That's the question. So as you can see, you can predict this, shape, almost it is same. Almost the pattern is same. See, Monday, Tuesday, Wednesday, Thursday, Friday, almost same. There is a little change, it's going upwards. Okay. So for my analysis, I need to take some data. So the data which I am considering is previous Sunday data for the analysis. This is the analysis I'll be taking for the analysis, for the analysis of the situation, okay? So, let's take that. This is the data which is again taken from daily reports, which are taken from POSOCO. This is a daily report. On 15th, previous Sunday, on 28th, 29th. 29th is the last Sunday. Before that, and much earlier to that, that's the 15th data, okay? When there was no such kind of COVID situation, it was the case. And this is 29th previous Sunday case. Clear? So again, for the sake of clarity, I'm removing this one and this one, green as well as this blue. I'm just removing. I'm only keeping 29th data for the analysis. Clear? Now again, we are more interested about this period because this is from 6 o'clock to 9 o'clock. 9 o'clock is the turn-off call, light turn-off call. So I'm more interested about this situation, not the entire situation. So let me focus on just this span, okay? So I'm just focusing on only this span. For every 10 minutes, I have the change, how the changes are happening. For every 10 minutes, there is a graph, okay? Which is again taken from POSOCO website. You can also check it, links are given. You just keep checking the data, then you will get a good analysis. Now, from this, what we can conclude is, at 6 o'clock, at 6 p.m. approximately, the load was too low, around 101 gigawatts. But around at 7 o'clock, around at 7 p.m., the load is maximum close to 117 gigawatt. So in this tenure, you can go back and see this is what the peak, okay, this is what the local peak, okay, which we are interested in. Yes, 7 p.m. and 117 gigawatt is a peak value and we don't have any issue with this. Now slowly it is decreasing. So at this point, means at 9 o'clock, previous Sunday, the load was 112.55 gigawatt. Okay, so here 101, here 112. This is a change which is experienced, due to which we are facing a problem. That's because of the light. And tell me why there is a big shoot over here from 6 o'clock? Because of the light. Okay, we're estimating this is here also given here. It's because of the lights. At 6 o'clock, sunset will happen. Then slowly we'll keep turning on the lights. So this change is purely because of the lighting loads. I mean 90% you can say. Okay, don't say you will turn on AC, all this stuff. Of course that will be there, but mainly it's due to the lighting loads. And this is not our main concern. This change is our main concern. This is a main concern for us, because at 9 o'clock, this is a change which is happening, and that difference is 11.3 gigawatt. Okay, that difference is 11.3 gigawatt. So we should all worry about that 11.3 gigawatt. Now let's analyze the situation a little better. At this time, at 9 o'clock, what is expected is this load will drop down suddenly to here. The curve will be dropped down to here suddenly. That's a drastic change. And now it will maintain for 9 minutes approximately. Again it will shoot up suddenly. So we should all worry about how to address this situation. So it's not just one difficulty here. Dropping is one thing and raising of the load is another thing. Both situations should be very well addressed by the load dispatch centers or generating stations. Now how to address this situation? Even government also says, ministry, POSOCO also gives their analysis from their website, the same number, approximately 10.3 gigawatt. This is in megawatt, I'm saying in gigawatt. 10.3 gigawatt will be the change. It's official information. Okay, and if you include the power factor, then this would be the 12.4 gigawatt would be the change. You can check region wise, different regions, how the change is going to happen, how much is the change, everything is clearly given here. Okay, now the generation capacity. If you have a look at the generating capacity, again from Power Ministry website, I have taken these details. Coal is having 54% of the share generating capacity, and gas is having 6.9%, and renewables, that is hydro, is having 12.5%. Renewable energy, wind, solar, all these things, they're having 23.5%. So we should allot these generating stations nicely so that we should be able to address the situation very nicely. So here my main concern, I'm not worried about much of renewable energy sources, because renewable energy sources you can immediately change the power generation capability by switching on, but hydro, gas and coal, we should make use of. I'm just suggesting, these are my views. Okay, I'm not a great expert to give conclusions to power grid or something. I'm just giving my conclusions. Anyways, the point is hydro, gas and coal are the main concern which we should focus on to address the situation. Now we know hydro and gas, we can change the power capacity. Almost in very short time. In very short time, we can get the power range, we can change the power capability. But coal is not like that. You know about it. I'm not going to get into the details of it. Anyways, let's come to the point. The point is, we should be able to address the situation of this decrease and this increase. Okay. Now, during this decrease, what will happen? Frequency will increase. During this decreasing time, when power is reduced, frequency will increase. And during this increasing time, frequency will reduce. We should handle the situation. Okay, means power, I am saying power means P and Q. We deal with two powers, active power and reactive power. As it is a light loads, we're not much worried about the reactive powers. Of course, I'll tell you how to deal with the reactive powers, a little change in reactive powers. Also, there are reasons we can discuss. But mainly, we should worry about the active power because of the light loads. Okay, frequency is directly related to the power, active power. Reactive power is related to the voltage. I'll talk about this a little while later. Let me now just discuss about the active power. Now, as this situation is predicted, present situation is predicted, what we can do is, during this time, power grids should operate during this time around at 9 p.m., just less than 9 p.m. We should operate complete grid frequency at around 19.8 hertz or maybe 85 hertz, something like that. At lower edge of we have a frequency band, right? There is a frequency limit band. Okay, 14.9 to 49.8 to 50.2. So we should be able to operate during this time. We should operate complete generations at this point because we're expecting there is a frequency rise. So within this drop, frequency will be raised to this level. Okay. And at this point, during this time, means around at 9:10 or maybe at 9:09 p.m., we should operate the frequency at this range, 50.2, at the maximum limit. Okay, at the maximum limit, we should operate. Now, at this time, what will happen? There is a increase in the power, there will be a decrease in the frequency, still that will be within the limit. So the operation guidelines will be around at 9 o'clock, less than 9 o'clock, operating frequency should be, all generators should be around at this frequency. When there is a change in frequency, increase in frequency, yes, it will go up to this. Then again, it will be dropped down to this. This is one thing. Okay, one thing. The second thing could be how to get this, meet this drastic change. How to meet this drastic change in power, increase in power. Okay, how to meet this drastic increase in power or drastic decrease in power. So this is a peak time, as situation is very well predicted 2 days before. So during these 2 days, during this earlier span also, we should keep hydro power plant in no operation. No operation as in just maybe at 5% rating or maybe 10%, at its minimum level operation. During these 2 days, there must be an operation. Okay, till this time. Why? So that the hydropower capacity, the water in the reservoir is not wasted, it is still there. Because at this time, to meet the demand, there is a huge demand. To meet the demand, these hydropowers will help. Because I told you hydropowers can instantly give the power or instantly it can be taken from. Instantly means within very short time it can taken off from the power. So during this short span, we should keep most of hydropowers into the operation. To withstand this, most of the hydropower as well as gas power plants also, because both can act instantly. Okay, so during this span, these two power plants will be of much helpful. During this span, thermal power plants, of course they will be operating, but not to meet this load, they will be operating at a minimum level. Okay, base load, to meet the base load, they will be operating thermal power plants. Are we clear with the situation? To address the situation, frequency changes. Hydro power plants and gas power plants should be into operation during this time. And before this, I mean, at this peak time or even before this, we should not operate hydropower plant at its maximal, maybe at 10% level, we should operate. So from this time onwards, during this span also, yes, hydropower will be there of very less share, maybe 10%, but here mostly they will be into action. Are you clear with this complete analysis? Now coming to this voltage profile. As we're not expecting great change in reactive power because of the light loads, our STATCOMs, these STATCOMs and all can very well work here. STATCOM and all, they will maintain the reactive power compensation, they will take care of it. Okay. And again, I must say another important point about the hydropower plants. Another interesting point. Here, to fill this gap, because there is a huge decrease in the power, to meet this gap, I mean to increase the, maybe to drop it to somewhere over here, we will keep during these 9 minutes or maybe before that till these 9 minutes, we can use pumped storage plants, pumped storage hydropower plants. Because pumped storage hydropower plants will act as a load, so this gap can be filled up. All all pumped storage power plants available in India, they can work as a load. So at this instant, means at 9 p.m, these pumped storage power plants can be taken off from the operation. Okay, so this gap is filled a bit. Now, what is your role to handle the situation? What you can do for this? You just need to extend your light off time for 10 more minutes. Tell everybody, or maybe for 5 more minutes. Just for 5 more minutes, stay in dark, stay still with the candles or mobile torch. It's okay. Just think that there is no power. Okay. Let your other equipment, except light, let your other equipment in on state during these 9 minutes of span. Okay. After 9 minutes, don't instantly switch on your lights. That will help your grid. And of course, you're not going to get any blast at your home or something. Okay. Because situation is very well addressed. For you to help a little 1 watt of power contribution into this power grid as an electrical engineer, you can still do this. You share this video with your friends, share this information with your friends. Thank you. And again, if you like our content, hit the subscribe button and don't forget to hit the bell icon for getting more such kind of updates. Thank you. See you in the next episode.